Hi, Algebra 2 people. Thought I'd make a video that goes over what my expectations are for your project and do some sample problems of similar problems or similar types of problems. So, what I have up here on my screen is something that looks a lot like the project that you're going to be given. And it starts off with problem number 1. It says a couple plans to have 3 children. And for each child, the probability that a child is a boy is 0.5, and the probability that the child is a girl is also 0.5. So we have 50-50 chance. Yeah, here we have a situation where they're either boys or they're girls. We're not going to consider anything else. And for each child, the probability that they're left-handed is 0.1, or like 10%. Which would mean the probability that they're not left-handed or that they're right-handed, because again, this is you're either left-handed or right-handed. We're not going to consider the case where they're ambidextrous. I guess we could, but we're just going to consider whether or not they're left-handed. And so if they're not left-handed, that would be a 0.9. Does that make sense? In both of these cases, my brain is telling me that this is a binomial distribution, that there's just two things. It's either a boy or it's a girl. They're either left-handed or they're not left-handed. So we're going to use this idea of P of X is equal to NC X P to the X Q to the N minus X. Let me write that down here. See, I just wrote that here. We're going to use this, and this should look familiar because that is, I don't have my book open to the right page, but that is the binomial distribution probability formula that the book gave us. And looking at this particular problem, we need to kind of decide what's what. So, find my document back. The number of children they're going to have is n. So if we think about this, n is 3 because they want 3 children. And it's asking us for the probability. If you look at this next little section, it says find the probability that at least 2 of the 3 children will be girls. Okay. So we're saying that we want at least 2. So let's look at the case where there's 2. That would mean X is equal to 2. And I'll show you what I'm writing here, right? So my N is equal to 3 and my X is equal to 2. We have 3 kids. We're wanting 2 of them to be girls. And let's look at our probabilities real quick. P, the probability that they're a girl, is equal to 0.5. And Q would be the probability that they're not a girl, is also going to be 0.5. So P is 0.5, Q is going to be 0.5. So 50-50 chance they could be boys or girls. We're just going with their information, okay? So let's do the calculation to see what's the probability that we have exactly 2 girls in this particular case. Using our probability model, we're going to say the probability that we get 2 girls is equal to 3, choose 2, times our P, which is 0.5, raised to the X power, that's 2, times 0.5, that's, again, Q is the probability that they're not girls, okay? So remember, when we have P and Q, P stands for the probability of what you're looking for. Q stands for the probability that it's not what you're looking for, okay? In this case, it's a 50-50 shot, so we've got 0.5 for both of these, but 3 minus 2, because you have n minus x, 3 minus 2 is 1, so that's the first power, right? I keep breaking the lead on my pencil. Drives me nuts. Pardon me while I try to get more lead out of my pencil. Or not. We can find a different pencil and it works. All right. So let's take a look at this by grabbing a calculator. We can just run this into our calculator, you see. On mine, I have a little probability section. So what I'm going to do here is go 3, choose 2 times 0.5 to the second power times 0.5 to the first power, and that gives me 0.375. Now, I want you to stop and think about this. That's strictly the possibility that you had 2 girls, okay? But that's not what the question asked. So let's go back and reread the question for a second. My question was, if I can find it back, my question was, at least 2, right? It says the probability, find the probability that at least 2 of the 3 children, right? We just calculated the probability that 2 of the kids are going to be girls. So there's another possibility, isn't there? That's the possibility that there's 3. So what's the probability that all 3 are girls? Because if it's at least 2 girls, then we could have had 2 girls, or we could have had 3 girls. So let's find out what the probability of having 3 girls is. Now, how does that change it? Well, our x is now going to be 3, isn't it? In other words, we're going to do 3, choose all 3 girls, right? Out of 3 possibilities, we choose all 3 girls. The chances of them being a girl doesn't change. That is, that P stays the same as 0.5, but X now is 3. We're looking for 3 girls, so we raise it to the third power. And the probability that they're not a girl, still 0.5, but now we're not going to have to the first power, but to the n minus x, that's to the 0 power. And we figure out what that is. Let's clear this off and do a new one. So we're going to do 3, choose 3 times 0.5 now to the third power times 0.5 to the 0 power. But hopefully we remember that when we're dealing with exponents, when we raise a number to the 0 power, it's just 1. So I'm really not going to multiply by anything other than 1. And so I don't need that term. Again, I'm talking about 0.5. 0.5 to the 0 power is 1, and if I multiply 1 times anything, it's just that thing. So I'm not putting that in my calculator. And I get 0.125. Okay? Now, how do we deal with this? Well, remember that the probability of A or B is going to be equal to the probability of A plus the probability of B, all right? Minus the probability that they're both, but you know what? We're not going to take on that situation. These are mutually exclusive events. So in this case, I'm going to take the probability of it being 2 plus the probability of it being 3. Notice I have those numbers up here. So that's equal to 0.375 plus 0.125. And if I put those in, notice I get 0.5. Okay, so that's really just the probability that we're going to get at least 2 girls when we have 3 children, okay? So, and that's with these probabilities. Let's go back to our problem now. Where's it at? Oops, wrong one. Because the other part was it's like, and that at least one of the 3 children will be left-handed. Okay, so we got to figure out left-handedness here. Notice that it says the probability that somebody's going to be left-handed is 0.1. That's like a 10% chance. So let's consider this. What's the probability then that they're left-handed? Well, I'm going to think back to here. My N is still 3 because you're going to have 3 kids. My X, however, is that one of them is going to be left-handed. I have to stop and think here. At least one of the 3 children will be left-handed. Now, what we did before is we considered 2 cases. The probability that we had 2 and the probability that we had 3. If we were to do this, we could say, well, let's do it three times. Oh, pardon me, yawning. It's the end of the day. What we had is the possibility there could be 2 girls, the possibility it could be 3 girls. If we test for left-handedness now, we could, and it works out just fine, we could say, well, what's the probability that one of the kids is left-handed? But then we have to also add to that the probability that 2 would be left-handed. And then we'd have to add to that the probability that all 3 would be left-handed. And rather than calculate this 3 times, what if we went the other direction? That is, what if we said, well, why don't we just calculate the probability that none of them are left-handed and then subtract from 1? Because 100% chance is 1, right? And we had this rule that said, if you know what the probability is of something happening, the probability of it not happening is just 1 minus that probability. We could say that is, if we grab the pencil, it doesn't work. What's the chances I'm going to grab the pencil? It doesn't work. 100%. But anyway, if we know the probability of what we want is like the probability of t, if we know that, then the probability of not t, remember not, would be 1 minus the probability that it's t. We're supposed to know this as well. We looked at it. We should know that by now. So to simplify the process that we're looking at here, the probability that they're left-handed is really 1 minus the probability that, or I should say, the probability that at least one of them is left-handed is going to be 1 minus the probability that nobody is. So let's do this. Let's go. The probability that 1 is left-handed, right? What's the probability I can find my eraser? Pretty good. I got it. All right. The probability that they're left-handed, let's write down what we're saying. Probability that left-handed is going to be 1 minus the probability that they're not left-handed. I'm going to say, oh, let's call it L prime, L naught. Anyways, so the probability then that nobody's left-handed is going to be equal to n, choose 0, because I'm going to choose nobody being left-handed. That's going to be 0.1. What we want is for somebody to be left-handed to the 0 power, that's x, right? And that's going to be multiplied times the probability that they're not left-handed, which remember our probabilities have to add to be 1. So it's going to be like 0.9 raised to the n minus, I put n here and I meant 3. 3, that is n. I bet my n is 3. Raised to the third power, because this is the n minus 3 minus 0. N minus x power, right? Well, let's see what we get with that then. Again, 0.1. See if I can move my arm here. 0.1 to the 0 power is just 1. And if you've worked with combinations enough, you'd also know that 3 choose 0 is 1. But if you feel more confident in putting it all in your calculator, I guess you could do that. But really, the only term that's going to give us anything is 0.9 to the third power. 0.9 raised to the third is going to give us 0.729. 0.729. All right, that's the probability that none of them are left-handed. So we can subtract that from 1 to find out the probability that at least one of them is left-handed. So 1 minus 0.729. 1 minus the answer gives me a probability of 0.271. Probability that at least one of them is going to be left-handed. All right. All right. Let's go back. See some of my other stuff here. All right. So what do we got? Up here, we calculated the probability that we're going to have 2 girls when we have 3 kids. The probability we're going to have 3 girls when we have 3 kids. And we said the probability you can have 2 or 3 is just add those two probabilities together, which we did here, and found out we got 0.5. Next, we said, what's the probability that at least one of them is left-handed? And we said, well, instead of having to do like we did up here, do the probability that 2 of them are left-handed and the probability that 3 of them are left-handed, and then also include the probability that 1 of them is left-handed, and then add all those together. We said it's much simpler to just say, you know what, if we know the probability of something happening, the probability of not happening is just to take 1 minus that probability. So we took advantage of that and said, well, let's do this. Let's do 1 minus the probability that none of them are left-handed. And so when we said, well, let's find the probability that none are, so we did that. We said, what's the probability that none of our kids are going to be left-handed? So we set that up, ran that number through, and subtracted it from 1 to find out that the probability that at least one of them then would be left-handed, and we got that. However, if we go back to the problem at hand, it says, let's find the probability that at least 2 of the 3 children will be girls, and notice it says and here, right? That's an and. That at least one of the 3 children will be left-handed. So we've calculated these probabilities independently, but we now need to combine them. Yes, combine them. And to do that, we should remember that the probability of A and B happening was equal to the probability of A times the probability of, that's supposed to be a B, probability of B. So the probability that we have at least 2 girls, right? And at least 1 left-handed is going to be equal to our probability that we calculated before. That was 0.5, that we have at least 2 girls, times the probability that one of our kids is left-handed, and that was this 0.271. And what do we get? Well, let's see here. Grab the trusty calculator. That's 0.271 times 0.5 to give us 0.1355. There's the probability we're looking for our answer. Ta-da! Right? Okay. So, because these videos are going to be kind of lengthy, I'm going to stop there. If you look at your first problem on the one that I gave you, it's very similar. And so use these same methods to find the probabilities that first question is asking for, okay? And then when you're done with the first problem, check into the second video that I'll make next and post as well. So good luck to you. That's how you're going to do the first problem on the worksheet. And this counts as a test grade. Yeah, so you want to do a good job on it. But I'm giving you some pretty good samples so you can look at these and figure out how they work. Good luck. Hopefully we'll talk to you soon.
9 bus 7 to base, 10-7 clear.
Thanks, Bus. All right, take care, guys. We'll talk to you soon.